Hello engineers, welcome to a new video on low-level design. In this video, we'll look at the observer pattern. I hope you're ready. Let's get started. So observer pattern is also called as publisher subscriber or pub/sub pattern. So let's start with the intent. Define a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically, right? So this is a typical publisher subscriber model. To understand this, we can take an example of subscriptions, right? So let's say I have my YouTube channel, right? So this is my YouTube channel, udaykiran.tech. And as a channel, I have provided three methods, right? So first is subscribe. Second is unsubscribe. Third is notify, right? So as a YouTube viewer, when you subscribe to my channel, let's say this is you, user. So when you click on that subscribe button, you are actually calling this method called subscribe on my YouTube channel, right? So when you call subscribe, I'm adding you to my list of subscribers. So these are my list of subscribers, user 1, 2, 3, and so on. And when you hit the unsubscribe button, you are actually calling the unsubscribe method, at which time I will remove you from the list of subscribers. And whenever I publish a video, you will get notified, because whenever I publish a video, this method is called, and this method will look into all the subscribers and notify each of them using some kind of a loop or an iteration, right? So this is how a publisher subscriber method works, right? So this would be a good time to subscribe to the channel if you haven't done already, because we are discussing the subscription model. You can test out the system to check if you are getting notified upon my every video upload, right? Okay, let's move on. So there are some other use cases as well for the observer pattern. So we can see this pattern used in alerts as well. So let's say you're using a weather application and you get notified via push notification or emails that the weather is changing drastically. So maybe there is the air quality index that is changing state from severe to very severe, or it is back under control. So these type of alerts are getting notified to you using the observer pattern, right? And another example can be orders, right? So you make an order, the order is going through multiple states, and at every stage you're getting notified that the order is shipped, it is dispatched, it has reached the nearest location, it is out for delivery and delivered, and so on, right? So whenever there is a need to notify somebody else when something else changes, so we can use the observer pattern or the pub/sub pattern, right? So this is the high level idea about the pub/sub pattern. Let's see how to implement the observer pattern using UML diagrams now. So let's go to UML. So this is the class diagram for the observer pattern. So on one side, we have the subject. Subject is providing three methods: attach, detach, and notify, right? So this is very similar to saying subscribe, unsubscribe, and notify, right? So when we say notify, we go through all of the observers and call upon update method. And who are the observers? There can be any of these observers, observer A, observer B. They're just using a common interface with an update method in them, right? So this is an interface for a subject, and a concrete subject like my YouTube channel, let's say, has multiple things. So in the private space, I have a state variable which will keep on altering the state of this subject, right? For example, I publish a video, it is altering the state of my channel, right? And I have a list of observers here. So whenever a new observer comes along, I will call the attach method. Whenever a subscriber unsubscribes, we can call the detach method. And whenever I change the state of my subject, I can call the notify method. And inside notify, I go through all the observers and call upon update for each of them, right? So this way I'm able to notify all the observers. And this pattern is helpful because it can grow on its own. So let's say I have a bunch of subscribers who want to get notified by email. So all of them can be here. Let's say I want to have subscribers that only want to be contacted by SMS. So I can have all of them here, right? So there can be different types of observers, but I can store all of them in the observers list so that they can be notified individually, right? So you can see the composition relationship here. So observers are getting stored in the subject, and when we call the notify method, all observers are notified. right? So that's the whole idea behind the observer pattern. Let's look at the sequence. So the client is creating a new subject. Let's say I'm starting a new channel, right? So new channel is created. And now there is observer A, who are users who want to get notified, let's say via push notification. So all these users are created under observer A, right? And then there are a bunch of users who want to be notified via email. So all these users can be in observer B. So all these instances are created and the client calls upon attach for each of them. So all these instances are now attached to the subject. So when we say attach, we are just adding them to the list of observers, right? It can be a vector, it can be a list of IDs and so on, right? And then we call upon set state. Set state is how we alter the state, right? So we have this state variable and this can be altered using the set state. This is a setter method. And when we change the state internally, the subject will loop through each observer and call upon update for each of the observer. So it will call upon update for observer A users and observer B users. So all of them will get notified at just one call of set state, right? So this is how the observer pattern works. So let's take an example. So instead of doing the typical YouTube system, let's take a weather system to keep it interesting. So let's say we have our subject and observer interface. So subject interface has attach, detach, notify, observer interface has update, right? And the concrete implementation is like this. So let's say we have a weather station as the subject, and the weather state is the state that we are altering. The weather can be sunny, windy, cloudy, and so on. So this is the state that we will be altering using the set weather method, right? And all the observers are added to the list of observers here. So who are the observers? There can be anybody. So let's say there are a bunch of TVs at our office that are displaying the weather and they all need to be notified, right? So all the TVs come under this observer, all the app users come under this observer, right? So both of them can be added to the list of observers. And when the state changes using set weather method, internally set weather will call upon the notify method, and notify will loop through all of these observers and call their update. So internally they can be notified, which will actually trigger the SMS or push notification or whatever, right? So this is the typical implementation of a pub sub model. So let's see all this in code now. So I'm in VS Code now and we have a new file observer.cpp. So let's first build our observers. So first we have a common interface for observer which has just one method update, and this will be implemented by weather TV and weather app. So both of them will have an update method which are just doing a simple cout, right? So weather app is taking a username, weather TV is taking a name. So we will see something like weather TV display 1 received an update for the current weather, which is like this, and so on, right? So these are my observers. And now let's look at the subject. So the subject has three methods: attach, detach, notify. So this is a common interface, and this will be implemented by the weather station, who is our concrete subject, right? So what will the weather station have? It will have a string for holding the current weather state, whether it is cloudy, windy, sunny, and so on. And it will have a vector of observers. So observer, as you can see, it is a observer interface, this one. And whoever is implementing this observer can be part of that. So weather TV can be part of it, weather app can be part of it. Together they can form the list of observers here, right? So what are the methods that it is exposing? The weather station is exposing attach method. So when we call upon attach with an observer, we are just adding it back as a pushback to the observers vector. So we're just adding one more observer to this. And when we call detach, we are removing the observer. Simple. And when we call set weather, this is how we are changing the state. So we are getting a new string and we are setting the current weather, and we are internally calling the notify method. So inside notify, you can see the for loop. So here we are looping through each observer and calling the respective update methods. Simple. So everybody will be updated. There can be a TV display, there can be app, there can be any other type of observer, right? So these are the classes. Now let's see the usage. So first we create a weather station, And then we create 3 TV displays: display 1, display 2, display 3, living room, office, and kitchen. So there are 3 TVs that need to be notified for every weather change. And then let's say there are some app users, user 1, user 2, user 3, who are part of the weather app class, right? And we will attach all these observers to the subject. So we call upon the attach method with display 1, display 2, display 3, user 1, user 2, user 3. After that, let's set our weather. This is our first update to our state. Set weather to sunny. So when we say set weather to sunny, internally what should happen? So the current weather should change state and internally notify should be called. So this will be a loop. So all these 6 attached observers will be notified, right? So after that, we are calling the detach method on the office display. So this observer should be removed from our list of observers. Once that is done, let's change the state again to rainy. So this time only 5 of the observers should get updated and office display should not be printed out, right? So this is the implementation. So let's run this and see. Now let's observe the output. So weather is changing to sunny. So who are receiving the update? Living room display is receiving the update, office display is receiving the update, kitchen display is received the update, and app user 1, app user 2, app user 3, they have all received the update, right? Now we are removing the office display, and after that we are changing the weather to rainy. Now living room, kitchen, app user 1, user 2, user 3 received the update, but office display has not received the update. So office display is unsubscribed from our list of observers, right? So this is how, by just calling one method called setWeather, we are internally calling notify, and everybody will be notified for this, right? So this is a useful implementation of the publisher subscriber model, right? Now let's see some trade-offs of this pattern. So by using this pattern, we are getting loose coupling between observers and subject. So observers can be attached and detached on their own without having to disturb the subject, right? So there is some loose coupling there. And we get open close principle usage here because there can be multiple types of observers and they can grow on their own because they are using a common interface. So it is open to extension, right? And the system is quite scalable because the number of subscribers or observers can keep on adding without having to affect much on the subject, right? So that way we are not restricted towards scale in this model. But scalability can also come as a weakness because as the system grows along, if the subscribers are also calling some other methods internally, very soon the system can get messy. So this model needs to be implemented very carefully. So there can be memory leaks possible, especially in programming languages. We don't have automatic garbage collection. So there can be leaks while unsubscribing from the channel. There can be objects that are lying around, and it can cause performance issues as well as the system grows bigger and bigger, right? So these are some things to keep in mind. So in this video, we have covered the intent of the observer pattern. We have seen example use cases, diagrams, code walkthrough, and also the trade-offs, right? So if you have any questions or inputs, definitely put them in the comment below so that I can learn and everybody can learn. Thank you so much for watching, guys. I will see you in the next one. Don't forget to leave a like if you found this helpful. Do subscribe to the channel if you haven't done already, and do share it with your friends. Thank you so much for watching. I will see you in the next one. Cheers.